Hello, hello. We are back for another episode of the Tech Behind FinTech. I have a special guest today, Souhail Mssassi. I didn't butcher your name, correct? Did I say it correct?
Yes, it's
Uh,
correct. Hi, Nnamdi.
Hi, that's very important to me. My name's Nnamdi Osuagwu. I'm the host of the Tech Behind FinTech. Today we have a very special show. We're going to talk about smart contract security and what you need to know. Before I jump into the show, as always, we have to officially introduce our guest and let me read his extensive bio. Souhail Mssassi, with more than 8 years of experience in cybersecurity as an offensive security engineer, specialized in application security, cryptography, and security of decentralized application. He assisted several organizations in improving their own cybersecurity strategy. He is also a security researcher in QuantStamp, doing audit of blockchain protocols, dApps, and smart contracts. And as an instructor and a speaker, he presented security lectures in universities and conferences, recently researching on formal verification in the cybersecurity field. Welcome to the Tech Behind FinTech. Thank you very much for joining me.
Thank you, Nnamdi, for the invitation, and hope that all of the person that are hearing us will be enjoying this talk.
I mean, the beautiful thing about these types of shows is whether they're hearing it now or they're hearing it next year, it's always something to take, and
Yeah.
that's why I really love doing this, and I love bringing guests as yourself on, and I love tackling some of the more technical pieces of the financial technology industry and financial services industry. I say that we talk about the power behind the money, but today's focus is on smart contracts, specifically around the Ethereum blockchain. So I know you specialize in that, correct?
Yeah. During my auditing or background, I have specialized in Ethereum smart contracts, but also in Tezos smart contract,
Okay.
Solana, and also some other blockchain protocols. But I began my journey in with Solidity and Ethereum smart contracts.
That's awesome. So, how we always do with the show, before we jump into the topic of hand, we go over some selected news articles that we just came across. We try to make it relative to the main topic of on hand. So we're gonna start that process right now. Let's jump into some news articles that we found, and we'll get to Hal's take on it. So the first one, record month for NFT sales, 900 million this month. Crypto Punks itself, I think they did around 400 million to add to that. They said let's get some takes on that. Yeah, so earlier this week, also the credit card giant Visa announced that it has purchased its own crypto punk for 49.5 ether, worth just under 150,000 at the time. They basically said, with our crypto punk purchase, we're jumping in feet first. This is just the beginning of our work in this space. Um, what's your take on that?
Yes, for there is a big explosion in the NFT now, and it's really impacted the blockchain community and also in the cybersecurity. Now we are getting more and more projects to audit, and now people are investing in NFTs. So yes, this month are very full of NFT projects, and each project is very unique than the others. So now, this is the moment, as we say, and as Visa also said, this is just the beginning.
And you know what? And so for the audience, it's really important to
Mm,
understand a few things. And I want to
mm,
kind of drop this with. I know everyone's been hearing about NFTs.
mm.
NFTs are created basically a program on a smart contract. So and that's our topic today. So when you look at NFTs, when you look at new tokens. It's based off of NFT in the Ethereum space, based off of a standard called ERC 721. And then when you see the other tokens you may trade, that's based on the ERC 20. So what does that all mean? Is that those are coded with smart contracts. So you look at like a Bitcoin or Ether; those are more native to those
native
platforms.
currency. Yes.
Yeah, but now when you look at other currency created on Ethereum based on that, those are where the smart contracts come into play. So it's really relevant to Souhail's specialty and what we'll be talking about and how to secure those smart contracts. Anything else you would like to add to that?
Yes, NFT now are very explosive, and of course the community should be aware also for scams, because now the bigger or more the projects are, and more the probability that there is some scams. So people should be aware of that.
I mean, that's 100% accurate. A lot of fly by night stuff. Let's move on to the next article. So all our articles probably today are going to be related to crypto, just because of the topic of the show. PayPal launches a UK crypto service. So essentially, you're going to through PayPal, you're going to be able to soon purchase crypto. So PayPal is launching a new service that will enable UK users to buy, hold, and sell cryptocurrency, the first international expansion of the service outside of the US. Users will have access to real-time crypto pricing. Yeah, I mean, my opinion, I think that's just the way the industry is going, and a lot of fintechs and financial firms are just jumping on board. What's your take on that, Souhail?
Yes, people is doing the great move now, but they should expand the service to more countries, because to be honest, there is other countries that are very interested in crypto. But also supporting different cryptocurrencies. So when I read this article, PayPal now support just four cryptocurrencies. So it's a good number for the beginning, but they should expand this cryptocurrencies to 10, 20, and why not to support all of different ERC 20 also with tokens? Why not?
Looking at it, I think it's early on. Maybe that's why they're trying to crawl, walk, run. But I totally get the point. It's more adoption. It's definitely going to expand in that space. Let's jump in to the last one. So this article and what's happening with Cardano, one of my favorites. They're anticipating their own smart contract launch with their Alonzo release coming in September, or I guess latest October. And found that totally interesting. And I want to get your take on it, being that you have a lot of experience with different platforms and coding smart contract. I think the language that they're going to use is a language called Haskell, and that's their environment. It's a Plutus playground where people can start playing around with Haskell. What's your take on that?
Yes, so Cardano now they want to challenge Ethereum, so they want to go full virtual machine and with smart contracts. And of course, when you are doing when you are adding this logic of complete Turing machine with smart contracts, you can literally do everything that you want. You can do all of you want to code, you can do it. Yes, they focus more on the difficulties that Ethereum have already faced. So we have different problems of Ethereum and smart contracts in Ethereum, but also in the language of developing the smart contracts, and it's called Solidity. So now, Cardano, they are using a very known programming language. So Haskell, it's a very known language. So if, for example, there is some developers that already known this language, they can migrate easily to create smart contracts on Cardano and doesn't need to learn a new other language. So yes, it's a big step for Cardano, and they should implement the smart contracts, but also they should involve the community of the developers, because a blockchain without the community of the developers, without innovators, they can't evolve easily.
Yeah, and I think I listened to something from their CEO. I think they have 3,000 developers, and they're going to start expanding it. I think in their playground and testing. But that's definitely a topic that we want to circle back on once they go live and talk through it. So without further ado, so I know let's jump into the topic at hand. Smart contract security, what you need to know. And before we get into that, can you talk to the audience, what is a smart contract? Some people may not be aware of it.
Okay, so before talking about smart contracts, we can talk about a normal application. So imagine that, for example, you want to access to Google, you insert, for example, the URL in the browser, and the client will send a request to the server. So in the server, there is some services and some programs that are a set of instructions. So the set of instruction, they takes an argument, they do some calculations, some for example some treatment, and they give us an output. So this is in the classical architecture, the classical web now that we already have. So we have a server, and this server is centralized. So we have a server that communicates with a database. It can be in AWS, Azure. So everything is centralized. Now, when we are talking about blockchain, we already had in the 2009 with Bitcoin, Satoshi, or the expansion of cryptocurrency, but some persons, and especially, for example, Vitalik, had thought, why not to expand the idea of financial the transaction to be decentralized, to program to be decentralized. And they thought about this, and they created the concept of smart contracts. So smart contracts are programs that have some logic behind. So it's like the classical program. It's a set of instructions that takes argument and return it, but they are executed in a decentralized way. So each smart contracts are executed in different machines, and these machines will verify the validity of this transaction, and if everything is okay, it's stored in the ledger. So with these smart contracts, I can, for example, do a lot of things, a lot of use cases in smart contracts. We can, Nnamdi has already told us, so we can create tokens, NFTs. We can do some, for example, voting contracts. We can create, for example, games with smart contract. Now we are seeing decentralized games. So yes, basically this is a smart contract. It's a program like a classical program, but they are deployed in a blockchain network, and it behave in a decentralized way, so no one can control this smart contracts or modify it.
So, I mean, those are important points that Souhail mentioned. I want to kind of express that to the audience. So, one of the properties of a blockchain is the decentralized aspect of it, right? That's a major component compared to, like, if you looked at cloud architecture, where you're going to one cloud provider and your stuff is central. Another thing he mentioned are the nodes and the deployment across those nodes of that smart contract. And another point that was mentioned was that it can't be changed, so the immutability aspect. So those are different properties. And in terms of use cases, it's endless. I mean, if you start thinking about a legal contract, right? And if let's just say all of the entities are just digital components, it's the concept of basically taking that paper contract and programming it and deploying it. Is totally autonomous, as Souhail mentioned. It's running as an application on the chain, and it's just going and going, right? There's other things we can get into in terms of the gas fees and the
Yeah,
different costs to run it, but it just from a simplistic point of view, I want you guys to think that this is a legal contract. They say code by law, that it's now deployed on the chain. Some of the things, right? And and also, so mentioned, it came out with the coming out of Ethereum back in like 2014, 15. But with all these good things, there have been compromises, right? The first known compromise was something called the DAO, the Decentralized
DAO
Autonomous
attack. Yeah,
Organization, right? And let's just put it in numbers, and I'm gonna get Sahil's take on it when we start getting into it. The compromise at the time was 150 million. It was like about 12 million ether. Today, that same thing is valued at 33
yeah,
billion based on today's valuation,
yeah,
or if not more. So, and that hack was a logic hack, and it was a time when the Solidity language was just a few months old, and it wasn't really fully security tested to the standards we have now. So, and this leads us into the auditing of smart contracts and why it's important. So I'll let Sahil take it from here. So
yeah,
Sahil, so yeah, so I mean,
yeah,
these
yeah, sure.
and
This as you mentioned, the DAO attack, it's a very famous hack, and he causes the fork to the Ethereum Classic, and also to Ethereum that we know now. And of course, it's when I will talk about it in the presentation. It's logical bugs, and of course, Solidity was a very experimental language, so it's very recent. But they pay, and a lot of contracts have suffered from this problem, and this problem is called the reentrancy attack. And now we are seeing a lot of attacks and hacks. The recent one, it's about the poly network. It's the biggest DeFi hacks. I think they recover all the money stolen, but I'm not sure about this. So yes, of course, it's very, very important to secure our assets, to secure our wallet, secure our DApp, secure our smart contracts. Security, it's something that's very critical, because basically, if, for example, we are developing a program or a smart contract, but without securing him, without security, maybe a hacker will go and access to my wallet, to my smart contracts, and destroy the business logic of my smart contracts.
so I mean that gets into a good point. Um, someone said something. We have a
Yes,
in the audience.
yes, Hassan. Oh, Hassan,
Is this
it's a friend of mine. I
okay?
think you record live, correct?
Oh yeah, this is we're totally live right now. As you can see, that's why we're answering on the spot, and then the recording will also be available on YouTube and other platforms afterwards, and LinkedIn. So we broadcast on LinkedIn, YouTube, Twitch, and Facebook. So we'll have all the recordings out. Hassan, thank you for joining, and please keep the comments coming. And any questions that you have throughout, feel free to ask them. We're live, and we'll answer them. Yeah,
Yeah. Just
so
to mention, Hassan also works in security, but in classical, in web application, mobile. So he is a CISO.
oh nice. And you know what? Look, and so we're doing some research with the Cloud Security Alliance around blockchain security and stuff like that. And my standpoint has been Oh wait, we have a question, but I'm gonna get into this question on one of our fellow guests. But my standpoint has always been, whether it's mobile, whether it's web, it's blockchain. We still have to think about application security. We have to think about certain practices we should put in place.
Yeah.
Like the whole concept of shifting left before deploying it. And I think the same thing holds true to smart contract. One of our guests and he actually owns an exchange, Niger Crypto, and he was a former guest on our show. Chiagozi Uwu. Let's see what he's asking. What's your opinion on rug pulls and other founder-based contract bugs?
Okay. So I think we can answer the question in the final slide when I finish all the bugs. But just to summarize, rug pull, it's like we can say it's a bug or exploit in the DeFi, and it's now it's very very known, and they are using some scams to exploit this contract bugs, but it's very 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 recent, and basically there is no solution to prevent to protect from it. But we can discuss we can discuss more about it in the end of the show.
No, thank you for that. And Chigozi, thank you very much for the question. And that's good for me because I'm gonna actually research that after the show. So please keep the comments, questions coming, and yeah, that's great. So do you want to you want to get into the slide and we walk through the slide as we keep the conversation?
Yes.
I'm gonna add it right now.
Okay, perfect.
You're in control.
Okay, great. So now we will talk the agenda of today. We are going to talk about three main important things. The first thing is the importance of security in smart contracts, why we should secure our smart contracts or our DApp. The second thing, it's about classical attacks or release scenario hacks, and we already talked about the DAO hack. And the third and the final thing, so from a perspective of a developer, so imagine that I'm already a Solidity developer. How can I do, what is the best practices or the security best practices to implement in my smart contracts? So the first thing is why we already need security. Each person or each entity in general, they have some special assets or some critical information that no one should access to this critical information. And of course, here it comes to the security. If, for example, someone steal my personal data, or for example, a hacker stole from a bank some data about clients. So this is a breach, and it's a critical thing. So the same thing, it will apply to blockchain and to Ethereum smart contracts. We should, of course, secure our smart contracts. And Ethereum now, if we want to compare it with classical application, like, for example, web application or mobile application, it's very, very recent. The other application or the other classical application are very mature, and they gain maturity in security. So it's more than 20 years than we have web application. But Ethereum, for example, it's just 5 or 6 years. And we see now other complex blockchain, and they are very experimental and very, very recent. The second thing, it's about the philosophy. Now this thing, it's the developer will understand this. Developing in blockchain, it's very, very different than the development in the classical applications. Yes, there is some common things. There is loops, condition, etc. But the philosophy of development in blockchain is very different. Imagine that, for example, you code something, and the smart contracts, it can be known to other persons, and they can view the code. They can, for example, verify this code, etc. So no one can, for example, change the code. For example, if you found you made a mistake in the code, you can't change it. So it needs, or it needs a very different philosophy. And of course, smart contracts, some or many, the majority of use cases use some use cases in the finance. So of course, hackers are searching for two things. They are searching to be famous or money. And smart contracts, in a way, you will have the two things. If you hack a smart contract, you will be famous, and you will get the money. So basically, what we are saying about security smart contracts, or they are a Disneyland for hackers. So if a hacker can hack a smart contract, he will be very, very rich.
A couple of things that you mentioned that I want to kind of like drill into, or highlight really, is with classical applications, as you put it, with web especially, right? The amount of experience we have as an industry. So I mean, look, a lot of time, well, not most of the times with security, unless you have like a 0-day attack, right? A lot of with applications we are securing, we've seen this before. So now we have common vulnerabilities that we secure for, and but for all those common vulnerabilities come out, it kind of takes time. It kind of takes someone, either if on the ethical side, exploiting it and saying, okay, this is a potential problem, let's put some security around it, or safeguard, or someone actually a company falling victim. We learn it and then we secure it. So the fact that it's so new and evolving right now, and so early in their lifetime, I like what you said with that. I just want to kind of highlight that. That's a really good way to think about it. It's still evolving. We're still learning. We're still figuring out ways. Okay, this is actually a vulnerability. This is the way it got compromised. Understanding how it was compromised, and then putting in some remediation aspects so others can learn from it.
Yes, and basically it's like everything is evolving. So the security guys are searching for some best security practice, or some security mechanism to implement. But also, in the other hand, we see hackers to searching for other different way to hack the smart contract, or to bypass the security mechanism, etc.
No, it's definitely a race, and both sides there. We're definitely evolving.
Yeah. So there is also another difference. It's the difference between blockchain and the classical application. In blockchain, if we are talking, for example, in Ethereum, everything is public. Considering the code of the smart contract, the transaction. So imagine, for example, if I call a function with some parameter in Ethereum, everything will know what is exactly this parameter, because it's public, and everyone can see it. So we can imagine that the blockchain, it's like a server, but the code, it's exposed to everyone. And Ethereum, it have a big surface attack, and there is some difficulties in Ethereum or in the smart contracts. It's at the same time, it's an advantage, but also it's a con or inconvenience. It's the immutability. So we already mentioned this. Smart contracts are immutable, so we can't change the code of the smart contracts after deploying it. So it's a good thing to know that the community will be 100% confident about that the developer won't change the code, or the company won't change the code. But at the same time, if we imagine that, for example, we find a vulnerability in the smart contract, literally we can't do anything, because we can't change the code. So we have to modify the code and redeploy again the smart contract. So even we discover the bug, we can't fix this bug.
That's also important to note, but we can put functionality in the smart contract to pause the to pause it and different things like that. You want to can you get into that, please?
Yes, we are going to talk about some design pattern, and one
Okay.
of the design pattern it's the posting. Yes, there is some security mechanism that should be done before deploying the smart contracts. Is the proxy pattern, the pull over push. So there is a lot of patterns that if the developer implemented these patterns and implemented very well, the smart contracts will limit the risk. And even if, for example, we find a vulnerability or a hacker wants to steal money from the smart contract, it will be very difficult for him to drain all the ether.
And it's cool because the even though there are different terms in terms of what you're mentioning in terms of the pause, it's not the same as necessarily a mobile app, but the same concept and the way of thinking about shifting left,
Yeah,
implementing security earlier on in their software development lifecycle holds true in this paradigm. So
yeah,
those are the things that I want people
yeah.
to understand.
It's called the security by design. So from the beginning, we should think about the security of our program and about the security architecture of the program. Not when we until we are going to finish the development of the smart contracts, and we will say, okay, we should do some audits or some penetration testing. But from the beginning, the developer should focus on the security part and also on the functional parts.
And we say developers a lot, but even in outside classical, right? Going through a threat modeling exercise, that could be a cross-functional team,
Yeah.
made up of not just the developers, but the same concept where Sahil is mentioning security by design. So doing a threat model even before you start coding, when we're just like, okay, here's what we want to build, and looking at the business use case, that's definitely an exercise that we take in various, whether it's classical, whether it's blockchain, and so forth.
Yeah, yeah. In the classical, we see also the sec DevOps or the DevSecOps,
My
and
favorite.
yeah, they're adding the security in the pipeline automatically. Hope to that someone will create a framework like this or a concept like this in the blockchain, because honestly, we there is no security, a perfect security guideline in smart contracts or a framework that focus on security of smart contract. There is open zipline or some public GitHub, but a framework with all of the things that already exist in the classical development. For now, they don't exist in blockchain.
You see, here's the thing that I would kind of argue with it, right? Where we are with classical, and we look at DevSecOps, and then we have looking at like a continuous integration pipeline, and we have all these different pieces within the application, right? That took time to evolve. So
Yeah,
I still say like, because it's something that I'm currently working with Cloud Security Alliance on this on a research paper like this, and that's the concept I'm putting out. It's like you can still apply DevSecOps to the blockchain, but it may not be as advanced as the classical,
yeah,
but it could be something as simple as you're coding in whatever environment you're coding in, are we doing some sort of static analysis during that process? And I would argue with anyone that even putting that little piece into the development cycle, that's a form of DevSecOps.
yeah,
It's just,
yeah,
but it may not be as intricate as what we see when we look at mobile and we look at all the different release gates and so forth. So
yeah.
that's a take that I have on it.
Yes, yes, so, totally agree with you. Of course, we can get some many features of DevSecOps, but it will lack, or we will have some problems due to the difference of, for example, the patching problem. So in the DevSecOps concept, when we are going to find a bug or a 0 day, directly we are going to change the code, push a commit, and deploy to the server. But in smart contracts or in blockchain, we are stuck. We will say, yes, there is a bug, but how can we fix it?
Not the limitations that you mentioned, totally on point. Totally agree with you. But then putting in certain parts to the development prior to deployment, I think there's similarities.
Yeah.
And you know, because it was a conversation I've been having with people, and even if it's not fully like we see in classical, where you have that continuous process improvement, where you're getting feedback and you're re-implementing into the design, I still think there's aspects we can take, and it's just not as advanced. But
Yeah.
but yeah, like I said, that's all. We could bring you back, and we could definitely have a whole in-depth conversation about that, because that's something I'm interested in as well.
Yeah. Why not? So to understand the security of the smart contracts or Ethereum, hackers or security responsible should understand the system, because basically a hacker is someone who know the system better than the developer, or know better than the one who creates the system. So we should understand how the different layers in Ethereum. So of course there is the DApp. The DApp, it's the decentralized application that communicates with the smart contracts. You can code it with we have the front end with HTML, CSS, JavaScript. But also we should communicate with the smart contracts with some kind of libraries, for example Web3. And in the layers of Ethereum, we have the Ethereum protocol and the Ethereum networking. So we have the Ethereum protocol with the consensus, for example, the transaction, the EVM machine, the concept of mining, etc. And also when we are talking about nodes, these nodes should communicate with them. So there is a concept of networking. We have, for example, peer-to-peer networking, node discovery, encryption mechanism, etc. So if we want to study well the Ethereum security, we should study each layer. But we can't, of course, talk about the security of Ethereum in 1 hour or 2 hours. But we will focus just on the application part, and specifically in the smart contract part.
You know,
So
that was. Can we look, guys? This is an excellent slide. Thank you very much for giving this information to me and my audience. I love it. Because you know it's aligned with what we talk about security when we talk about defense in depth, right? Like, so it's totally on point what you're saying. Excellent slide, and great points with mentioning the different components, and not just looking at smart contract, but the other aspects of it. Excellent stuff, man. Thank you.
Yeah. Welcome. So now we want to zoom a little bit about the G app. So here we have the smart contracts. We compile the smart contract with a Sol compiler. We have a different version of the Sol compiler. Now we have the version 0.8. And after compiling the contracts, we have the binary of the contract. We deploy it in either in the test network or in the main network. And after the deployment, we have the contracts will have an address, a public address that will communicate with the who want to communicate with the contract. He will call this address. It's like the classical wallets. We have a public and a private address. A public is used to identify myself in the network, but the private one, it's for verification or signing the transaction. So now we are going to talk about some classical attacks and real scenario hacks. And the first one, it's the DAO attack or the DAO hack. And it's very interesting here, a code, because this 5 lines cause a catastrophe in the Ethereum community, in Ethereum in general. So here in the smart contracts, and as I already mentioned, the smart contracts are just a set of instructions. So if you are already familiar with coding, you find kind of some similarities with the classical one. So here, for example, we have a variable called balances. So it's a mapping. It's like a dictionary that will set keys and values. And here we are mapping addresses, public addresses, with the an integer. So basically we just tracking the balance of each user. And here we have a function called withdraw. So in this function, the user will call the withdraw function, and they will give it a parameter x as an integer, and the contract will do some verification. So the first verification, it's when you want to withdraw some amount of money, you should already have this amount of money. So here it's just a simple verification of saying that I already have this amount to withdraw. And if everything it's correct, the second line will transfer or send this ether to the person who called the withdraw function. And the third, after of course sending the or doing the transaction, I will subtract the balance, or from the balance the amount of X ethers from the balance of the user. So now everything seems okay, but of course there is here a problem that cause the fork of Ethereum and cause a lot of problems in the smart contracts. So to illustrate this, here we have two contracts. Here we have the first contract. It's the vulnerable one, the DAO contract, and it have as a balance 200 ether. And here we have also another contract. It's we can say it's the contract of the hacker. So of course, I mentioned that users can communicate with smart contracts, but also smart contracts can call another smart contracts. And here the hacker did a very smart thing. So they created a smart contract called attacker, and it have two functions. So the first function, it's called start attack, and the second function, it's a function without name. So in Solidity, it's called a fallback function. A fallback function, it's a function that is triggered when we call a function that they didn't exist in the smart contract. For example, if we are calling a function called stop attack, the Sol compiler will verify there is no function called stop attack. So automatically he will call this callback function. We can view it as a default function. So if for example we don't find any function to call, we will call the fallback function. And inside the start attack function, we are calling this smart contract, and we call it with the withdraw function. So we are giving, for example, 100. So what is here the problem? So the problem is what we call the reentrancy attack. So now when the smart contract will call the DAO contract, it will do the verification. This verification, for example, it's okay. They will send they will send 100 ether to the contract of the hacker. But here the problem is what when we are sending some ether to smart contracts, automatically the fallback function is executed. And in the callback function of the hacker, we are going to call another time the withdraw function, but without subtracting the amount. So imagine we are going to transfer or send the amount of ether, and in this line we are not subtracting the X amount. So the smart contract of the hacker would call withdraw an infinite times, because of course this verification will be all true all the time, and the contract of the smart contract of the hacker will drain ethers from the balance of the DAO contracts. And now this is a problem, and this is why it's called reentrancy attack. So we are going to re-enter the function, but in an infinite amount, because directly when we are sending ether, we are not going to go to this line, but we are going to call another time withdraw function. It's like an infinite loop. I don't know if I explain in a correct way the vulnerability.
I think you'd explained it in a great way, actually. And I like how you broke down the fallback function and so forth. The question I would have for you, right, is we understand. So now, in hindsight's always 2020. But if this company, let's say they had a decentralized, this was a company right now, and they're trying to do the DAO, and they came to you and said, okay, listen, we wrote this. What will be your approach to finding, okay, this has a potential re-entry vulnerability?
Yeah. So first of all, there is some what we call some internal audits, and there is some external audits. So now we are talking about security audits and how can we find this kind of bugs in the smart contracts. Of course, developers, to limit this kind of bugs, they should do some security best practice and also some security design pattern. So here in this case, for example, if the developer has implemented a security pattern, and we will talk about it later, this problem of reentrancy won't happen. But here the fix of this vulnerability is very simple. You should just switch the two final line. So the balance, the call function to the smart contracts, and the variable, the subtraction, we should invest the line, but because essentially in some security best practice, external calls should be done in the first lines of the instruction and not in the first, because we will have this kind of problems, this kind of reentrancy attack.
Interesting. Not totally good stuff and breakdown of the DAO hack. That excellent. And listen, to the audience, if you have any questions on this, please feel free to drop it in the comments at any point in time, while we're live. I know we're going over, but this is some really interesting stuff. So in terms of, I'm saying, going over to our normal time, this is some interesting stuff. So we're going to keep diving in, but please shoot any questions you have. We're having a master's class right here at security audit. So this is good stuff.
Yeah, so the second problem here, it's what we call transaction ordering dependency. So imagine, for example, if we have a smart contract that do some, for example, a logic of a marketplace, and we have a seller and we have a buyer, and the seller, for example, he will create an offer. So, for example, selling 10 tokens for 1 Ether, and the buyer is very happy with this offer, so he accepted. So this is a normal transaction. But imagine, for example, the seller want to update this offer. So he want to sell 1 token for 1 Ether. So if, for example, here we have 3 transactions. So for example, if we have the seller make the first transaction, create offer, the buyer will accept this offer, then the seller will update the offer. So it will be okay, because the buyer will buy 10 tokens for 1 Ether. But imagine if the miner, because the miner have this possibility to the mining of the transaction. Imagine if the miner, for example, called the create offer first, and after he called the update offer, and in the last thing he will call accept offer. So here the buyer will buy 10 tokens, but not for 1 Ether, but for 10 Ether. So he
Souhail, you paused on us. Just want to make sure it's not on my side. Souhail, pause. Let me private chat him. We may have lost connection. All right, guys, we're just I think we have I'm just chatting him. I think we may have lost the connection. Give us a second. Let me see. We come back. All right. He's gonna log back in. 1 second. So listen, all interesting stuff today, what we're discussing and breaking down smart contracts, looking at patterns. Definitely when you if you revisit this video, and Souhail's breakdown of the DAO attack and talking about reentrancy. So while he does that, let me share some stuff. Let me share some tools with the community and some resources. So, as we were talking before, so here's some tools, right? So, some static code analysis tools in Slither, dynamic code analysis tool, and Mithril, both open source, and a VS. I think we have Souhail back. Let me add him. Hi, Souhail. Can you
Okay.
hear me?
Yes, yes, perfect now.
All right, cool, cool, cool. Yeah. So in the short break, I was just going over some tools in terms of
Cool.
we mentioned
Yeah.
before static code analysis, dynamic code analysis, and so forth. If you want to reshare your slide, I'll put that
Yes.
back up.
Yes. All right.
Yeah, let me okay, yep, it's back available. Okay, let me remove this. All right, so we'll just jump back into
Mhm.
Souhail's presentation.
So I was saying that imagine that, for example, the miner switch the order between the update offer and the accept offer. The buyer will buy 10 tokens for the amount of 10 ethers, and of course, the buyer here we won't be happy for this offer, and the seller will gain 9 ethers. So here it's a problem that's very, very difficult to tackle in Ethereum, because the miner have this ability to change the order, change the timestamp of the mining transaction. So it's very, very difficult. Yes.
How would the miner do that exactly?
Yeah.
Um,
Yes. So basically, the miner, he have the right to input or to manually validate the transaction in any order he wants. But of course, he have some limits. He can of course do this kind of manipulation up to 900 seconds. And it's the notion of time, or the concept of time in Ethereum, it's very, very different. I can mention, for example, in Solidity we have a variable called now, and this variable now will reference to the exact time of the miner when he will execute the transaction. But the miner can manipulate this value, and of course he can also manipulate the order of the execution of this function. So it's very difficult to control the miner to respect the order of the functions. And sometimes, even for example, the miner is legit. Sometimes they don't do this in a purpose, with a purpose of hacking the smart contracts. But yes, this problem, it's a very big problem in Ethereum.
no, that's interesting. So how would and I mean, and that kind of brings up to the point you mentioned before, where you look at the different components and we start looking at security in depth. This is interesting. So how would one protect themselves against a transaction ordering dependency?
Yes. So basically, it depends on the developer here should focus more on the architecture of the smart contract. So from the first thought, he should think that, or focus that the miner, he can control time and he can control the order of the function. So sometimes he can include, for example, announce or a timestamp in the function, in the call function, and this nonce, it's like a number that will behave like a sequence number of the function, and it will be signed. So when, for example, the smart contract will execute this function, it should have, for example, that create offer has a sequence number of 1, accept offer sequence number 2, and update offer the sequence number 3. But if, for example, he have execute create offer the sequence number 1, and directly call update offer with the sequence number 3, he will see that the number 2 is missing, and the transaction should automatically be reverted.
Interesting. Now that's something a lot of these topics we're discussing, definitely let's use this as a starting point, and then definitely Google and research and drill in
Yeah.
more to get a deeper understanding. But it's good to be aware of it, and this way we can kind of dive in. And I know, guys, we're gonna go over, like I said, this is an interesting talk, so we're gonna go over our normal schedule and just dive deeper and let Souhail go through his presentation because he's discussing some really interesting points. Definitely, if you have a question or comment, definitely add it to the post on the comment side.
Yeah, so the third concept is the integer overflow. So here it's a very common problem that we find in smart contracts. And basically, it's something related with how the EVM machine works and also the memory size of variables or of types. So imagine, for example, we have a variable, for example, called balance, and this variable it's set to 0, and in the next instruction we do balance minus 1, for example. So in the classical language or in maths, 0 minus 1 it's equal to -1. But in the EVM machine or in Solidity, they don't understand a negative number. So for for Solidity or for the EVM machine, 0 minus 1, it will be calculated or seen as a very big number, and all the logic of the smart contracts will be very, very different if we subtract or if we have a negative number. So from going to 0, for example, we are going to have a great or a big number in our balance variable. So of course, to prevent from this kind of attacks, OpenZipline has made some libraries called SafeMath, and in SafeMath we can use some function like the add function, sub function, and they will of course verify if there is any integer or integer overflow or underflow, and they will revert the transaction.
So, and it's important to note. So, he just mentioned a company that's really known for creating these libraries, whether it's in different contracts and so forth. And that's really will go into a pattern of using verified components. So, like any level of like object-oriented programming languages in Java or whatever you look at, is a concept of inheritance. So you can inherit from other components and libraries, right? That's all part of general programming languages. With Solidity and these smart contracts, you can inherit from another smart contract. So looking and leveraging known secure smart contracts that you can inherit from, that's definitely part of a good security practice that you can implement when you're developing this stuff.
Yes, yes. As a security practice, you should implement functions that are already secure or audited, or smart use contracts that are already audited, but not creating other smart contracts or other algorithm mechanism, and maybe we'll find some vulnerabilities in it.
Exactly.
So now we are going to talk about some best practices and security patterns. Of course, there is more than 30 or 40 common vulnerabilities in Solidity. We can't discuss all of these vulnerabilities in 1 hour, but we are going to focus on the defensive side of security of smart contracts, because there is two different things. There is the offensive way and the defensive way, or the red team and blue team. So now we are going to put the hat of the developer and see ourselves as a developers, and how can we secure our smart contracts. So of course there is some access restriction in our code. So imagine in the classical application we have some API, and this API, for example, they will return to us some critical information. So of course we should do a middleware or a verification to verify if the one who is calling if it is authenticated, and if there is any it is authorized to do this kind of action. The same thing here is in Solidity. We are doing this by some function that we call modifiers. So these modifiers are some kind of function that will verify some condition, some access restriction. And for example, in this case here in the function change owner, for example, we call the modifier that is called only by. So here basically what we are verifying is that the message that sender is refers to the address of the one who is calling the function. It should be equal to the account or the owner account. So here it's the same thing. We are just verifying if the one who is calling this function, it's the owner of the contract. And here we are verifying the authorization of these persons who are calling smart contracts. So access restriction is a very important thing in security patterns. And of course, if you want to prevent some persons to call some function in your smart contract, you should implement access restriction. We have also what we call the check effect interaction. So we already talked about the DAO hack or the DAO attack. So to reduce the surface attack, we should avoid making some external calls before doing some modification in the variables of the smart contracts. So basically it will prevent us from reentrancy attack. And here in this example, we see the correct way of doing the function withdraw. So here we are subtracting first the amount from the balance, then we will transfer this amount to the user. Also, we have what Nnamdi mentioned. So it's the emergency stop. So imagine, for example, we find a bug or a vulnerability, and the hacker is draining money. So we should stop the contract from being executed, or some function to be executed. So some security pattern, it's called the emergency stop. And of course, the intention here is to disable some critical functions. And of course, you should, and this is a concept in security in general, you should always be prepared to potential failures. So here, for example, to see the code, here we have two functions, for example, a function called stop contract, and calling this function will stop some critical function to be executed. And here, for example, we have the deposit function. So imagine that, for example, the deposit function, in this case, it's a critical function. And we have two modifiers. So the first modifier, it's called stopped in emergency, and he will verify this variable is stopped if it's set to true. Now, in the creation of the contract, is set to false, but every time he will verify if it's set to true. And the second function, stop contract, he is doing a modifier only authorized. For example, we will prevent the persons to call this contract, and only the owner can call this contract. And basically, this function, he will do a simple thing, is to set the variable is stop to a variable true, to the Boolean true. So when the owner will call the function stop contract, now is stopped is set to true, and this modifier will fail and cause the transaction to be reversed, and will stop persons to deposit ether in the contract.
No, that's really interesting. I like it. That's really interesting stuff. Just how you can stop it like that, because once you deploy it, some people may not know, but you can plug in, like, if there's an editor called Remix and different things like that. Once you deploy something, you can test it, and you can plug in these values manually. So that's interesting. Good stuff.
So now we are going to the last slide. So there is some general rules to how to be safe. as a developer. So the first thing is don't write fancy code, don't write complex code. So the more the code is complex, the more it's very difficult to test it, and the more difficult is to secure it. So of course you should keep the thing simple and use audited and tested code, for example from OpenZipline. So the second thing is the third thing is to do unit testing. Unit testing, it's a very important concept, and you should test your contracts to behave like the way that you expect to behave. And of course, there is a lot of discussion about unit testing, formal verification. So it's a very huge topic. But the concept here is to write some unit testing and to test each function and to view if it matches the specification. An additional rule is also to be prepared for failure at any time in any contract, any execution, or any method. Deploy carefully, of course, because when we are going to deploy the contract is immutable, so we can't change it. And also a very interesting concept is called the bug bounties. So bug bounties will it's like we are going to reward hackers if they find, for example, vulnerabilities in our smart contract, but they won't exploit it. But instead of this, they will report it to the company and also give us some recommendation on how to fix this. So big bounties, it's a very interesting concept, and of course, as a developer, you should be aware of some properties of blockchain, some weaknesses that we discuss, and use the security patterns, and also implement some security mechanism as a developer. So this is the end of my slide. So if you have any question, or Nnamdi, you have anything to add, you can add.
No, I mean, I think you covered it. And one of the things that I wanted to mention is, look, from a security perspective, whether you're in the blockchain, classical apps, or looking at networks, whatever you're looking at, right? A lot of the things on this list hold true no matter the domain that you're talking about. I mean, we always talk about, the more complex a system that you build is, right? It's difficult to secure, right?
Yeah.
As the complexity increases, it's not. Sometimes you have they call it tribal knowledge, in which the people that are there, but other people that come new to the org may not understand it. They may not know how to fully secure it. That's what's on Souhail's list, but he's talking more about smart contracts. So, yeah, with the list, I like that. More complexity, more attack vectors. So don't write fancy code. Use audited and tested. When we start looking at the software supply chain in the classical apps, right? You want to use you want to source libraries that have been validated, that are the latest and greatest, and things of that nature that they're secure. Because you can look at various breaches outside, like the Equifax breach and things of that nature. You look at deploy carefully, right? Understanding your deployment model, prepare for failure at any time. So what's your disaster recovery, what's your DR, what's your incident response plan? So my whole point is, like, a lot of these things on the list kind of hold true, and it's just really taking that security mindset and applying to the blockchain. Obviously you're going to have certain nuances. So no, excellent work, man. I really appreciate you stopping by and going through your slide. I mean, definitely amazing. I mean, I was asking a lot of questions because I'm looking too, like the audience, and I'm like, this stuff is good stuff. So it's definitely going to be a video people can circle back to. How can people find you if they wanted to learn more?
So basically in security of blockchain, you should learn two things. First, you cannot secure a contract and you don't understand, for example, Solidity or how the blockchain works. So the first thing is you should be very advanced in Solidity development, Solidity assembly, how Ethereum works, what is the consensus used in Ethereum, how the other protocol is doing some general concepts. For example, what is a DAO, what is a DeFi, how DeFi is working, how some lending protocol. So everything you of in blockchain you should understand it. Then you can focus more on the security parts, and of course it will be very helpful to the persons to have already a background in security in classical application, because there is a lot of similarities in classical and in blockchain. So if you have some knowledge in cryptography, in web application security, it will be very helpful. But and then you can use some platforms like Ethernet that give you some challenges or some problems to solve, and to to exploit some vulnerabilities. So OpenZipline have a great some great documentation about some security best practices. There's also some Git repo, or also Consensus has some great resources in security of smart contracts. So my advice is to do the first step, to go and to search more and more in Solidity and Ethereum, and based on the way of based on how many of smart contracts you will be auditing, you will accumulate an experience and a knowledge, and you will have an intuition of finding automatically or finding some patterns in the smart contracts to find to find some vulnerabilities in smart contracts.
Yeah, so excellent advice. How do you want to promote your class, and how can people find you? Because I know you have a class teaching penetration testing and smart
Yeah,
contracts. You want to
yeah,
point people to that, and also how do people
yes.
find you?
Yes. So, if, for example, you have any question, or you want to send me a message, you can send me over LinkedIn or Facebook or by email. And also, I'm an instructor at EduBlocks. So EduBlocks is a very known YouTube channel that do learning stuff in blockchain. And if you want to learn more in the cybersecurity of smart contracts or blockchain, you can go to EduBlocks directly. And of course, I will be more than happy to help you to advance in your career in security of smart contracts.
Not excellent stuff. Once again, thank you very much for coming on board. Thank you very much for your deep dive in your presentation. I think it's beneficial, and I like the reason I mean, I'm a fan of social media and these types of videos, because what happens is a person can look at this next year or 2 years from now, and then wow, gain so much insight and circle back. So thank you for contributing to that effort, and it was really good talking with you. Do me a favor, after we close out, hang out in the green room. I just want to talk to you offline,
Yeah.
and guys, we're gonna close it out right now. uh you know this was let me remove this too. Oh, you know what, it's some tools I was talking about, and you know what, let me put it in there's some consensus due diligence tools. I'll put it in chat, and I'll
Mhm.
circle back on LinkedIn, because on LinkedIn I can't post from this tool, so I need to post directly on LinkedIn. But that is some links to some diligence tools. Also, here's a link to known vulnerabilities in Ethereum. So I just put that out there in the chat. And this is a good blog on the history of Ethereum smart contract hacks. I'll put that information out as well. So that was posted on YouTube, Twitch, and Facebook. For my LinkedIn people, I'll circle back after the show and put together something and put a comment so you guys can do further research. And also, so he'll posted his information, so you could just look at the video where he did that and copy that down. Once again, thank you very much. We're going to end the show at this time. Have a great weekend. Oh, last announcement. Next week, September 3rd, we are off. We are off. It's our first week off in 43 episodes. So every week we've been here. We're going to take off next week, September 3rd, and we'll be back for a new episode on September 10th. Once again, thank you for your time. Thanks for tuning in. Always a pleasure. Hang out, Souhail. I'm going to talk to you offline. That's